This is Miss Sebastian, and we're going to be working on polygons in the coordinate plane. Okay, each point has been reflected over the x-axis or the y-axis. So we have to decide which one has been reflected over. So all you're going to do here, we've got our point 49. So if I wanted to plot it, just so we can get a picture of what we're looking at, I could put A here and A prime at 4, negative 9. Okay, and if I was looking at where it flipped over this line. Okay, and that's our x-axis. Okay, I can look, the x value did not change. So because the x value did not change, we know that it didn't flip over the y-axis. So if we look at B and B prime, okay, I've got 5, negative 5, and then negative 3, negative 3. Because the y value did not change, we know that it flipped over the y-axis because only the x value changed. Okay, and we can check that by plotting that point. We've got 5, negative 3, and we've got negative 5, negative 3. Okay, so it flipped over this line or the y-axis. So I'm going to look at C, and I've got 1, 7, and then I've got negative 1, 7. Well, the y value stayed the same, so we know it flipped over the y-axis. Okay, so 1, 7 was here, and negative 1, 7 is here. So it flipped over this axis. Okay, now we don't need our graph on this one. You could continue to use it if you like, but all I'm going to do is look and see which value stayed the same. And on this one, on L and L prime, the x value stayed the same, so I know it flipped over the x-axis. Okay, I'll look at my second question. I see 7, negative 8, and negative 7, negative 8. My y value stayed the same, so I know it flipped over the y-axis. N is negative 6, negative 2, and negative 6, 2. Okay, the negative 6 is the one that stayed the same, so I know that it flipped over the x-axis. Okay, what is the coordinates of the reflection? And it asked me, reflect point D across the y-axis. So if I look at point D, it's right here. That is negative 3, negative 2. We're going to reflect it across the y-axis. That means my negative 2 is not going to change. But we're reflecting over this axis. So it's still going to be at negative 2, but it will be, the only thing that changes is the sign of the x coordinate. So it'll be at 3, negative 2. So that'll be our first one. Okay, reflect point C across the x-axis. So here is our x-axis right here. Okay, and C is at 0, negative 5. So if we flip it over the x-axis, the x value stays the same. The only thing that changes is our y value, and it's just the change in the sign. So it'd be positive 5 or 0, 5. Okay, let's the reflect point C across the y-axis. So the only thing that changes, we've got 0, negative 5, because we're reflecting across the y-axis, -5 stays the same. And I've got to change the sign of 0. Well, 0 doesn't have a sign. So if I reflect it across the y-axis, it's going to be the exact same number. So my answer is 0, -5. Okay, which of the points does not change its location when reflected across the y-axis? So remember, the y value will stay the same. The x value is the only one that changes. The only value here, I've got -3, 4, 0, or -6. The only one that does not have a negative sign is 0. So this is your answer. Okay, point R is located at 11,5. Point S is at -1,5. What is the distance between point R and point S? So all I have to do, I've got 11,5 and I've got -1,5. These two are the same. The only thing that changes are 11 and -1. So I've got to subtract these two. 11 minus -1 is the same as 11 plus 1. So that tells me it is 12 units. Okay, point G is located at 8, 1. Point H is located at 8, -14. What is the distance between these 2 points? So I've got 8, 1 and 8, -14. Okay, the only thing that changed was my y value. So I'm just going to subtract these two. 1 minus -14 is the same as 1 plus 14. So that is 15 units. Three vertices of a square are 1, 2, that's A, 4, 2, that's B, and C is 4, -1. That's C. So we need to find what the fourth vertice is. Now, we know that the fourth vertice will have the same x value as one point and the same y value as another. But we can also say, okay, there's 1, 2, 3 units between these two. 1, 2, 3 units between these two. We know that this is a square, so we are going to say 1, 2, 3 units. And then we could check it by saying 1, 2, 3. Checking that all of those have the same distance between the points. So the other vertice would be at 1, -1. Okay, so this one says 3 vertices of a rectangle are 1, 1, -5, 1, and 1, -2. Okay, so a rectangle is going to have 1, 2, 3, a distance of 1, 2, 3, 4, 5, 6. Okay, and in a rectangle, we've got the same distance over here as on the right-hand side. So that would be 3, and 1, 2, 3, 4, 5, 6. So this one would be D, and that would be -5, -2. 3 vertices of a rectangle are 1, -2, that's A, -2, -2, that's B, and -2, 4, that's C. Okay, so we're going to find the distance on the side. We've got 1, 2, 3. And remember, on a rectangle, they have to be parallel. So we're going to have a distance of 1, 2, 3 here. So most likely our point is going to be at 1, 4. But we could check it by checking the side lengths. 1, 2, 3, 4, 5, 6. And then A to our new point should be the same. 1, 2, 3, 4, 5, 6. So our fourth vertice would be at 1, 4. Two vertices of a right triangle are at 3, 1 and at negative 3, 1. Okay, let the side connecting points A and B be the base of the triangle. That means the bottom. Okay, the triangle has an area of 18 units squared. And we know that the area of a triangle is 1/2 times the base times the height. So the area we know is 18. So this would be 18 equals 1/2 times the base times the height. We won't know what the height is until we solve for it. So let's see what the base is. It's 1, 2, 3, 4, 5, 6 units. Okay, so all I need to do now is multiply here. 1/2 times 6 is 3. And now we've got to get the 3 away from the H. So because it's multiplied, we're going to do the opposite and divide. So the height is 18 divided by 3, or 6. So then I could start with B. And I could say 1, 2, 3, 4, 5, 6. And I would know that this point is -2, 7. Now you could have also gone up 6 points here and found a right triangle there. Or you could have gone down. You could have done anything as long as the height was 6. Okay, two vertices of a triangle are T, -5, -2, and W, 2, -2. Okay, that is going to be the base of our triangle. So I'm going to go ahead and find the distance of the base. I'm going to count 1, 2, 3, 4, 5, 6, 7. So I know that base is 7. And it's going to give me the area again. And it says the area is 28 square units. So I'm going to plug in what I know. I know the area is 28. And I know my base is 7. So I can do 1/2 times 7 and get 3.5 or 7/2. Okay, if you would rather deal with decimals, that's fine. But we're going to divide both sides by 3.5 or 7/2. And to do this, I'm going to say 28 over 1 times 2/7. And I get 4 times 2 is 8 over 1. So just 8 is my height. So I always like to use the left side just because it helps in my head. 1, 2, 3, 4, 5, 6, 7, 8. So my new point could be at -5, 6. And I could draw that triangle.